Okay, so what we're going to talk about tonight is kind of related to what we were talking about in terms of building buildings and taking little pieces and putting them together. Now, we know that the Houdini building generator, when it works, makes things extremely simple because it handles all the in essence, taking the pieces and putting them together in essence, some kind of in matrices. And you don't have to think in those terms. All you have to do is you say, I want A, B, and C, C, B, A, etc. And you can get it built in the way you wish. However, in cinema is trying to catch up a little bit here. And they have, in the last few releases, created their scene nodes, which are kind of adding Houdini-like qualities, different methods that you can use to construct things. And I looked at several different tutorials. One was from, I believe, this is from Hello Lux. And they did something very interesting. They did not use a scene node. They basically did a little loop to demonstrate how this thing called a loop carry works. What a loop carry does essentially allows you to loop across things and perform actions. So you see this kind of construct here. So let me get rid of this. This is not needed. Let me save it. Okay. So with the loop carry value, what you have, and I'm going to bring this range up so we can see everything together. I'm also going to bring it closer in here. So we have here, if you look up, these we're not using. We have a cube, and then we put a scene nodes deformer, which we call multi-extrude. So we gave it a name. And let's see something. I want to go up here and see if I can find, if that's what's called. I don't know if it's really called a scene nodes deformer, actually, if that's the right name. But it's basically a, let's see, if they're calling it multi-extrude. And it has to do with scene nodes. So let's see if we can find the name here. And we'll look at our asset browser and we'll look at nodes. And we're going to get rid of this. So one thing nice is they do different icons for different types of things. So geometry primitives and geometry selection and geometry generators, geometry utilities, and various other things. So what do we got here? This is geometry access, geometry orientation, it's, maybe that's something he named it. But at any rate, this is a node that essentially takes a geometry in and a geometry out, and extrudes the name that he gave it. So I am not sure what it actually is without going back. But at any rate, he, in this thing, he does a loop carry value, which has this, which is the values that it's spitting out, and you have also in our loop carry value, loop carry value takes a range, and this is the range. Then we have a count also, which you can get from the range. Now, I would think you would have to kind of hook that up. No, it didn't like that. It would need to go in. You'd have to have a variable for it. And then you have a count, and the count is basically the top of the range. If you do something like this, let me see if I can do a print. The best way I found so far to debug this stuff is to use this FX print and stick it here. And I don't know if it's going to print anything, but it doesn't look like we're getting anything out of here. And that's because we're not really taking this value in. So we could do something. Let's see. I'm trying to think where I can put this. Well, you can use a print. Let's see if I can put it. Let's delete this and see if I can stick it in. See if it's going to print anything. Now, this one thing with this node carry seems to take a lot of time to recalculate everything. But you can see if you go back here and you look at this range, I found if it got above 5, it was, but if I take it down, you can see it's this and then 2, 3, and what it's doing each time is it's extruding, doing a random selection, subdividing, so it's doing the same thing to this geometry that's put in. So then I was trying to see, well, how can I put something together, somewhat of a wall? Well, I tried that, and I was able to get this thing with points, and then because what was happening is, the reason this doesn't work is because just like we deformed it each time, it's moving it down each time. It's not creating a new one. So then I watched Noseman. If you're familiar with Max on their YouTube channel, he's on there quite frequently. And this is the one. So I looked at his video and I followed along. I did some things differently. I mean, he was actually doing a choice of multiple geometries. I decided to limit it to 2, which is essentially a blue plane and a copper plane. And this looks really, his looks even scary. It looks scary. It's really not. So let me explain and try to run you through. Basically, I have 2 separate matrices that are joined together in this null. Now, I believe I could have also had another matrix, another out, and then attach the two outputs to the C node. That's the thing. The way he didn't use the first example, they didn't use a C node. I did, and following Noseman's example, I did use a C node, and you have to. I found if I did use the object group that was recommended and I didn't connect it to a C node, I didn't have any output. Initially, it was connected directly to the C node. But the advantage of doing it this way is I can parameterize it, so it becomes similar to an HDA. Right, we saw HDAs where you can have different parameters and so forth. So anyway, I am sure there's a way to promote them. I just have to look that up. But the idea would be you can actually, when you go back here, you'd be able to see other parameters from your object group. So that is the idea of putting them in something like an object group. So let's move on from here. So there are two things that need to go to create these walls, if you will. You need something to tell it. You need the little pieces and something to tell it where the pieces go. So let's start with the pieces. So I basically took a plane and I made two different versions of it. One had a blue material, one has a copper material. This children's op is critical because it allows the material, this plane that's now these ops to get passed to a switch, because the switch, it wants let's see, what it wants is packages that have everything you need about the these inputs here. So that's what this does. This is basically converting everything into something that the switch can handle. Because what the switch is doing here is it's basically taking deciding which of these two we're going to see. Now, what you need is since it's a switch, you need some kind of index that tells it, well, is it this one or that one? Now, in this case, we have a very simple compare. This is a compare. It's like an if statement. Very, very simple. It's saying if our input is input 1, which comes from the height range, so that's where you are on the height, is greater than or equal to 2, then we're going to set it to 1, to this item, the second one, which is copper. Pretty sure it's copper. Yeah, it's the copper. If it's less than that, it's going to be blue. So you see here, you have copper on top and blue on bottom. Now, I was experimenting with some randomization. I've not gotten to look at noises yet in this context. Noseman does cover that. And noises are always a way of getting some randomization in your whatever it is you're working on. We use it a lot, of course, in materials. So the way we're doing this here, we have a hash. And a hash does generate, in this case, a random bool. And that can be true or false. I have had a print in there before, and you could see it was printing true or false. So this compare, what it does is it, again, in this case, it's looking to whether it's 0 or not, or true or false. The hash determines true or false based on a seed and the salt, things that give you randomization coming from the height range and the width range. And they determine what these values are. And thus we got this checkerboard pattern here. So that's how we determined what is going in our wall, for lack of a better word. The other thing is we have to now construct the wall. Well, the way they do that is you have to take the values from the range. So we have a height range and a width range, and also I used a depth range on this one on top, and I'll talk about that in a minute. So the height range is how high you want, width is how wide. We multiply, since each of these squares are 100 centimeters, what value, remember range, what's coming out of range is a series of numbers, 0 to whatever, or whatever your range is. We multiply that by 100. That tells me where it is on Y. Do similar thing with the width and tells me where it is on Z, the Z-axis. And then we take that, we put these in here and make a 3D vector, which we put in the translation, which is part of this compose matrix node, which will actually feed the vectors into this matrix operator. And the matrix operator takes what's coming from the composed matrix. So you think of it, composed matrix takes this set of points, values, where we're going to put the blocks, and it sends these vectors to the composed matrix. Matrix operator combines that with, so we have this is how we turn this result, which is a package, back to an operator. So we send that into that, the locations and the items. And this one on top is the same, except what I did is I added this additional depth range, which is actually now set to basically a depth I made it 4, since we're going to treat it like the range at the highest value. We can actually, what we could do is, no, sorry, this is the end. This is the end. What we just do is we take the count. That's right. We take the count. We stick it into the first value instead of the range. You notice down here we're using the range. We're saying we want 1, 2, 3, 4. Here we just want the one value, which is going to be 4. Or actually it's 0 through 3. And we're going to use that. We're going to do this multiply by 100, right? We're going to use that to compose, to get our location, but instead of x being 0, as it is on the other one, it's now going to be farther away, hence we get the second wall. Now, to get the other two walls, what you would do is simply swap the x and Z here. And then for the object going in, let me show you that. The plane has an orientation. You would switch the orientation from X to Z. And on here, you would swap on the what you're going to swap is X and Z here as well. And then this one, for the bottom one, obviously we have here, we have Y and Z. We just moved this to X. And of course, change the orientation. And then, so you have these various walls, you have to bring them together. And a couple of ways you can do this. What I did is, remember we have the two matrix operators. When I just had the C node, a C node can have multiple outputs, or inputs rather. So if you look at the C node, we could add another one here. What I did here is I used a null, which is, in this case, acts like a merge. And I just gave it the two children and plugged them in here and plugged that into op, which is the output of the object group. And again, we can have multiple children here if we wanted. And then plug that into the scene root. For the object group, you have to have the scene root or you're not going to see it. For this other one here, this first one, let's go here. This is a loop carry, but I was looking at something else. Oh well. So this multi-extrude is, see if I can get up, click on that. Is it going to, no, it's only going to read these. But at any rate, in this case, we're taking geometry in. Because we have the geometry in and we're sticking this under here, we can do geo in and geo out. I think that's the difference. Whereas here, here, when we just have, the only thing in here is the plane. We're not putting our stuff, anything under here to create the thing. We're doing everything in scene nodes. There is a data inspector here. So what you can do is, let's say you go here. I think you should be able to see, you can see stuff here. The other thing is there is a print function that'll print out what you like, although sometimes it'll make it not work. But they have this. I have to look into this a little bit more. Now, enable heat map will tell you how fast, if something's causing calculation issues. So that's one other thing you can do. I don't think we need that here. Where we may need it is, this is the one that was it this? Here it is. This is the one that was acting kind of weird. You can see I enable it, and I may have hung my cinema here. It didn't. Oh, so we do have it. And we can see this transform element is the problematic part. So that explains, and the whole point of the transform element was to move things along, not working as one would hope. So anyway, let's as you can see, it obviously it's more hands-on than or you constructing things at this point more than you would with with Houdini, which has an actual tool designed to build, these different structures. But you can see it once you do it, it's kind of, there is some straightforwardness to it. It is not that scary. There were some things along the way that were a little tricky, but again, Noseman's tutorial was very good. Just this whole concept of turning things into packages so that you can use it in other things. It's like anything in programming, right? Certain methods, and you can think of these boxes as methods in many cases. Not the FX are more like a function. Like this is a switch space, and an if. This is more of an if. But these other things are more like, especially the green ones here, are more like methods. It expects a certain input and it's going to give a certain output. And even some of these basic functions, like the switch, wants certain inputs and has certain outputs. So you have to be aware of that. So sometimes you will have to use these data transformation type methods, such as this add package op. So what does this do? It's taking a package, which the switch wants a package, in this case. And the reason and this is something you can set now, because this is the way to get everything passed along. You can set these data types, and these more sophisticated ones come on from this far right arrow. So this is set expecting a package. And so to get it back to an operator, you need to you need to use this, which is designed to take a package and spit out an operator, which is what this matrix operation wants. Operator wants an operation as input. And again, you can notice it can also take different transformation values, which is, again, what we are passing to that here. So, to summarize this whole thing, Maxon in Cinema 4D is building out a node-based tool that will provide some Houdini-like elements, and it will get more sophisticated as we go on, Houdini-like elements to cinema. That's one thing to understand. That may explain why you can no longer just bring, connect HDAs directly to cinema. They're trying to make it more self-contained. And as you can see, you can construct, for example, if these were, you can use this, straight. This is just a plane. We're not you see when you pull this in here, they call it a classic plane object. So you can, and this doesn't have to be a plane. That would be an interesting experiment. That's more like it. And so this is, let's look at this. This is compared to what we have. Okay, this is 300 by 300 by 200. Okay, so that just changes our range. But let's see what happens. Can we drag this in? And what is it? And this is a classic object. Okay. So let's see what we can do here. We're gonna have to change our ranges. So it's instead of 100 by 100, it's 300 by 200. So our height range is, this would change our multiply. So the height is 300. And the width range is 200. And I'm going to say this is 200. And we're going to, well, let's start with this one here. Where is our, let's see something. Let's bring this. And well, that's interesting. It coming in as it is coming in as not okay. So for some reason, this cube is not. Ah, that's interesting. Okay, no, we still have the points here. Well, anyway, I'm gonna play with this. That'll be interesting to see if I can get this thing to come in. But at any rate, we now see how you can do something similar directly in Cinema without needing to, let's get this out of the way here, without needing to use Houdini. So anyway, that is where we are today. So we've seen two different ways that we can make something. One is a bit more mature, although it's still a bit buggy because it does not want to work in Unreal Engine. Now these objects, these things we're creating here, should work, be able to input into Unreal Engine, because you just export them as an alembic, and Cinema, or you can actually take them in, I believe, as a Cinema object now. So anyway, hopefully this has been helpful, and thank you for watching, and I will speak to you next time. Take care.